Good morning to all. Myself Vasavi. I am from second civil. I am purchasing second BTech first semester. Today my topic is discuss about perspective geometry of aerial photography. In this slide, introduction to perspective geometry in aerial photography. First point, perspective geometry explains how three-dimensional objects are representing in two-dimensional images. It is essential for understanding the spatial relationships and distortions in aerial photographs. Third point, accurate interpretation of aerial images relies on grasping the principles of perspective geometry. In this slide explains about fundamentals of perspective in photography. First point, perspective refers to the way objects appear smaller as they are further from the camera. The point where lines coverings in an image is called the vanishing point. Perspective influencing by the camera's position, orientation and lens characteristics. In this slide explains about types of perspective in aerial photography. One point perspective occurs when the camera is directly above the subject with all lines converging at a single point. Two-point perspective is seen when the camera is tilted, causing two sets of parallel lines to coverage at two points. Three-point perspective involves the vertical dimension, adding depth to the perception of height and elevation. In this slide explains about effects of camera position and orientation. First point, the height of the camera affects the scale and distortion of the features in the photography. Second point, the tilt and roll of the camera influence the perspective and can distort the apparent shapes of objects. Third point, proper control of camera orientation helps in minimizing unwanted perspective distortions. Fourth point, the height of the camera affects the scale and distortion of the features in the photography. Fifth point, the tilt and roll of the camera influence the perspective and can distort the apparent shapes of objects. Proper control of camera orientation helps in minimizing unwanted perspective distortions. In this slide, explain about vanishing points and their significance. Vanishing points are where parallel line appear appear to appear to meet in two dimensional way. Second point, they provide clues about the orientation and position of the Second point, they provide clues about the orientation and position of the camera relative to the ground. Third point, identifying vanishing points is crucial for accurate measurements and mapping for aerial images. Fourth point, vanishing points are where parallel lines appear to meet in a two-dimensional image. They provide clues about the orientation and position of the camera relative to the ground. Sixth point, identifying vanishing points is crucial for accurate measurements and mapping for aerial images. In this slide, discuss about distortions due to perspective. First point, converging lines can cause objects to appear distorted, especially near the edges of the image. Again, converging lines can cause objects to appear distorted, especially in the edges of the image. Second point, relief displacement occurs when taller objects appear shifted or stretched due to perspective. Third point, understanding these distortions allow for corrections during image of interpretation and analysis. In this slide, discuss about mathematical foundations of perspective geometry. In this slide, explains about mathematical foundations of perspective geometry. In that first point, perspective projection can be described using mathematical equations involving similar triangles. Second point, the principles of collinearizing and vanishing points are central to understanding image formation. Third point, coordination transformations help in converting aerial photographs into. Second point, the principles of collineating and vanishing points are central to understanding image formation. Third point, coordination transformations helps in converting aerial photographs into accurate spatial representations. Fourth point, perspective projection can be described using mathematical equations involving similar triangles. Fifth point, the principles of collineating and vanishing points are central to understanding image formation. Sixth point, coordination transformations helps in converting aerial photographs into accurate spatial representations. In this slide, explains about applications of perspective geometry in aerial photography. In this slide, explains about applications of perspective geometry in aerial photography. In that first point, it aids in photogrammetric tasks such as height determination, mapping, and 3D modeling. Second point, perspective analysis helps in orthoretification, correcting distortions for accurate measurements. It is used in urban planning, environmental monitoring, and military reconnaissance. Fourth point, it aids in photogrammetric tasks such as height determination, mapping, and 3D modeling. Perspective analysis helps in ortho certification, correcting distortions for accurate measurements. It is used in urban planning, environmental monitoring, and military reconnaissance. In this slide, explains about technique used to mitigate perspective distortions. First point, using nadir images reduces perspective distortion significantly. Second point, ground control points are employed to calibrate and correct perspective effects. Using nadir images means vertical images reduces perspective distortions significantly. Ground control points are employed to calibrate and control perspective effects. Advanced software algorithms can automatically rectifying perspective induced distortions. Advanced software algorithms can automatically rectifying perspective induced distortions. In this slide, finally, we will talking about conclusion and future perspectives. A true understanding of perspective geometry enhances the accuracy of aerial image interpretation. Ongoing advancements in sensor technology and processing algorithms continue to improve perspective correction. Mastering of perspective principles is vital for the effective application of aerial photography in various fields. A true understanding of perspective geometry enhances the accuracy of aerial image interpretation. Ongoing advancements in sensors, technologies, and processing algorithms continue to improve perspective correction. Mastery of perspective principles is vital for the effective algorithms of aerial photography in various fields. Thank you for giving